Hello everyone, can you hear me? Alright, so hello everyone, can you hear me clearly? Alright, so is my voice clearly audible to all of you? This is Sandeep Giri here. It might be showing Nishant ji. Alright, alright. So, hi Abhishek, Girish, Sirisha, Carl. Okay, finally I am able to see your response. Okay, great, great. So everybody is able to hear me, and it's just that I'm getting a little bit delayed response. All right. Okay. Okay. So where were we during last discussion? All right. So I think we asked this question before leaving the last session. Okay. Correct. I think this is what we had finished this particular question. So before we proceed further, do you have any questions for me? Yeah. Assignment number 6 problem set. What was the Oh, you mean the pig one? Okay. Okay, so Girish is saying that the lab files are missing for each sessions. Okay, what do you mean by lab files? Do you mean to say that the files you created in the account of student, that file? So uh, I think okay. So Girish, I did not get which lab file are we talking about? Oh, correct, correct. So so actually, right now we have created these accounts Hadoop 1.5, but we have not deleted the older one, as in we have not deleted the student folder yet. Okay. So what you can do is you can still log in as student, all right, and and get the data from there. If you have your data there in that other one, I think I will also copy my data. I will also copy my data and yeah, I'll do that tomorrow. Thank you for reminding. I'll just copy the data to a common folder, public folder. All right. But for time being, you can use the student login as well in this. You see this one. So is everybody able to use this terminal? Okay. Okay. So Girish, if you can help me out with which one we are talking, I'm actually guessing and I'm waiting for your feedback. So, do you mean to say the data that we require for these sessions, like for these examples, are you talking about that data or you're talking about something else? All right. So, before I receive your response, I will try to copy the rest of the data. Till then, till then, you can receive. Just a second. Is it that? Yeah, I'm not speaking. Yeah, Girish. So what I expect from a student is that they should be able to form. They should be able to form their the sample data from the problem statement explained here. His question is that the lab file and data is not available. You can actually go over this data set. Okay, everything is available in the labs, and maybe we can have a discussion as to what you're pointing to. So if you require sample data, let's say for this second problem or the first problem, you can create the data set out of these examples and start doing it. Okay. And I will not be providing the solution, like ripe solution at hand. Okay. I would expect the users to provide the solution which I can review. Okay. Okay. So I mean, the data and sample is all available in the problem statement itself. You can prepare the files out of this sample data and start working on that. All right. All right. Let's start with our regular discussion. And if you have any questions, right, just drop me an email at Hadoop at no big data. Okay. And we will solve the problem. And Kirupa, let me also check the Hadoop 15 after this session. If you are not able to log in using Hadoop 15, then we will try to solve that problem. All right. Okay. So Girish, we can have a discussion over the phone. Which sample problem solution are we talking about? Okay. If you log into LMS, most of the problem statement and with the data is available in that problem statement. All right. We can have a discussion, separate discussion about that, or just if you want, we can have a separate call, right? All right. So here is another question for you in continuation with our discussion in the previous session. So let's say you have two data sets, A and B, and we are saying join A by ID and B by ID, left outer semicolon. What is what is the output of this? Anyone? What will be the output of this? All right. Yes. Thank you, Savita. The answer is incorrect statement. Okay. Left or right outer has to come before comma B. Okay. Only then it makes sense. All right. So statement is wrong. Next question is, if I say join A by ID, then outer comma B by ID, what will be the result? Anyone? Yeah, anyone? What will be the result of joining A and B in this fashion? Join A by ID, then outer, then comma, then B by ID. Yes, anyone? Abhishek, Arvind, Damodaran, Girish, Sirisha, Kalkamp, Krupa, Praveen, Santosh, Savita, Subbareddy, Urs. All right. Yes. So Carl and Savita and probably Arvind. Yes, you're right. It's it's an error. Okay, because we need to mandatorily specify left or right. If you do not specify outer, by default outer will be assumed with left and right. But you need to specify left or right. Okay. All right. There are few more things. One is limit, as in if you want to read first 10 records, then you can simply say limit your dataset and then 10. That will give you the first 10 records. Or if you want to just look at 5 records, then it will be limit divs 5. This is fairly faster. If you are just testing, if you are running your pig queries and you are not sure about your pig queries, so what you can do is you just create the first data set out of with the 10 records by putting a limit. This will make your whole process really fast. Okay. Now the next one is sample. Sample is for randomly picking a percentage of total record. Randomly, if you say sample divs point 0.1, point 0.1 is equal to 10%. Okay, so if we say pick up zero point 0.1 fraction of the total number record, it essentially means 10%, and it will give you randomly 10% records. Okay, and again, since whenever we say random numbers, it's generally an approximation. If you have 100 records and we are saying 10%, it not necessarily mean that it will always return exact 10 records. It might become 9. Okay, or you can think of it the other way. If you say 50% of 3 records, 50%, and there are only 3 records, so how much will you get? So it's generally an approximation. And also sample is a very important function when you deal with the statistics or when you deal with big data. So when your program is like functioning, is not giving any compilation error, or it's not giving any syntax error, at that point of time you should change limit to sample so that you can test your application over a sample instead of only first 10 records. So since this sample will pick up any 10% records or any X% of records, your script will get tested against random subset of the records. Yes, so Abhishek, when I was talking about 3 records, that we start with 3 records, I we have 3 records and we say that give me a sample of 50%, you might get one or two, either one. So Arvind's question is, do we have an equivalent Unix command for sample? Okay, I this is a very good question, and I don't think I know. I'll just make a note of it. All right. Okay. So I hope this is clear to you. Now, here is one important question. Let's say we load a file, tab separated file, divs, Then we pick 10% records. Then we pick 10% record of that data set and we dump that sample twice. Okay. Do you get exactly same result both the times? Or they will be two different subset of the whole divs. Okay. So every when you say dump sum twice, will it give the same results or will it be different? Anyone? All right. So every time, so here, I think everyone, all right. Here, the important part you should understand is the moment you say dump, the whole process of computing sum and hence computing divs will happen twice. Okay, there is no caching happening anywhere. And when we say div equals to load something, it does not mean we loaded the data into divs, meaning we cached the data into divs. No, it's just a statement saying div means load this file. Okay, but div does not contain the data. It's just an expression saying whenever somebody try to ask for div's data, give him load file.tsv. Okay, so every time you execute this dump statement, both of these statement will happen again. Okay, every time you say dump sum, there'll be sample and then there will be load. All right. So Arvind and Santosh, is that clear to you? Great. All right. So as we told earlier that Pig has been designed for performance and at that time we did not support our point with any example. Okay. And this will also prove that for some things Pig is Pig is better than Hive, as in using SQL. Instead of using SQL, you might like Pig more because of these reasons. One of such reasons is parallel keyword. Parallel keyword gives you more control over how many reducers will be created underneath. Okay, so whenever you are saying group by or the reason I was asking you continuously about how many whether reducers will be created or not. The reason was you should know what's happening underneath. If you do not know the reducers and mappers are being created underneath, you will not be able to optimize big scripts. Okay, and as we told you earlier that when we say group, there is a reduction happening, meaning reduce phase will happen. And reduce phase will, in reduce phase, we can specify that we need these many reducers. Okay, the way we were specifying while reducing, while executing our map reduce job, we were specifying how many reducers we want. In the same fashion, we can also specify here. Why? Why do you need to specify? Why are you not relying on Pig's way of selecting number of reducers? Because you know about your cluster better, as well as you know about your data set better than pig. Okay, therefore most of the time you can optimize it better if you do not specify number of reducers. Pig does a reasonable amount of guessing. It does a reasonable amount of guesswork in the sense that it will basically try to create one reducer per gigabyte data. If it you have 2 gigabyte input data, it will create two reducers. If you have 10 gigabyte of data, it will try to create 10 reducers. If you have, but it does not go beyond 999 reducers. Okay, so that's the default logic. In case you have, let's say you have 2000 2000 or yeah, let's say you have 2000 gigabyte data. 2000 gigabyte data, how many reducers will we have? Anyone? If we have 2000 gigabyte input data, how many reducers will be there? As I was telling you, that per gigabyte data one reducer will be created. So it will be 999 reducers. Reason being that it does not go beyond 999 reducers. All right. All right, Abhishek and Girish. Great, great. Now moving ahead, and so parallel is one keyword which lets you control any statement where there are reducers. It does not impact any mapper. Okay. In case there is no reducer, parallel statement will not have any impact. Okay, so you generally append your statement with parallel. In case you are seeing that there is a too much of repetition of this parallel happening in your statement, you can set as a default, like set default parallel equals 10. Then you don't have to specify parallel on per statement basis. All right. So next question to you is, how many reducers will it produce? Anyone? Correct. It is just the mapping phase. There is no reducer phase. So, does parallel clause will have any effect on this? Will parallel clause have any effect in this statement? Great. So, yeah. So there is no effect of this parallel clause in this sentence. And why? Because this statement does not have any reduce phase, meaning there is no sorting happening, there is no reducer happening. Because if you have to do the same thing, like what exactly are we doing here? For divs, generate only one column called symbol, right? That means we can do that in the map phase itself. for each record we'll just print only symbol, right? So that we can do very well using the map phase itself, and we do not require any sorting or any reduce phase. Okay, therefore there will not be any reduce phase. Pig will detect it, and pig will not execute anything in the reduce phase, and therefore there is no impact of parallel 10, as in number, because parallel only controls number of reducers. Make sense, Srisha? All right. Okay, Praveen is saying that queries in pig, are they similar to NoSQL queries like join etc? No. Actually, as a matter of fact, not all SQLs, not all NoSQLs provide query languages. It's only few which provide you proper query languages. And they have their own mm, way. And most of these NoSQLs don't even provide you a way to join two datasets. Okay. Uh, so Damodran, your statement, your assumption is correct. All right. Moving ahead with the discussion. Okay, so lot of time what happens is when you are dealing in the real world scenarios. In the real world scenarios, you might have to call a lot of times, you might have to call the legacy functions. And when I say legacy, it means things like you have some stock trading algorithm, you have some method, some executable which need to be which is the only way to do certain operation. In those cases, you can call those external functions using using pig. Okay, so there could be many scenarios. First scenario could be that there are some functions which are available in Java but are not available in pig. Okay, that in those cases you can use the first syntax. Okay, you can use a first syntax where you say define hex and you give the name. So hex is the new name for the method which we are invoking. Here we are invoking a static function called toHexString, and we are passing int argument to that function. Okay, next is next is that we call hex function. Okay, we call hex function. You can see that we are calling a hex function on the volume. So this is how we can call a Java function. Now there could be another scenario that you have some other jar containing, this is your legacy code that you want to use. In those cases, you can basically say register acme.jar and then define this and then execute those functions. All right. Next is that we can call using Python function like register production.py using Python as this. So all the functions which are there in this production.py will become available to your script. Okay, to your script like this. So if there is a function called production inside production.py, then we can call that function from within the pig module or pig script. So Savita's question is, in Pig, when we load data into cache, till how long will the data be available? So we don't load any data into cache. There is no syntax to load the data into cache. This statement might be looking like I'm caching the data, like divs equals to load, but no, we are not loading any data into cache. It's just a statement and which will get executed only at the time of dump. So these statement will not have any impact unless we call dump or store. So yes, this particular method java.lang.integer.toHex is a Java built-in method. Now Carl's question is, when you register, do you have to be in the same directory as that of Java or Python file? That is correct. Thank you, Carl, for mentioning that. So when you say register acme.jar, it should be in the same folder from which you started the pig. Okay, and if you are using a web interface does provide you a way to register a jar, but that is a little bit buggy and does not work all the time. Yeah, so yes, we can call the custom functions. All right, now you could try out this user defined function, and I'll also demonstrate to you this. Okay, so all right, you can download this zip file, import it into Eclipse, okay, and that will be your big one, and then you can export the jar and then copy it to the server and then say register pig udf.jar. All right, now here, all right. So let me try to. Okay, so here there'll be a project called pig udf. All right, and under pig udf, let me just open the project. All right, let me see what is wrong with this. Okay, so pig UDF will be somewhere. Yeah, here it is. Okay, and where else is it? All right, I've just unzipped it again. All right, now it will be in this folder. I'll say file, import, existing project into workspace. I will go into this. Let me just drag and drop this to here. All right, great. What else? Let me, yeah, this is better. Where did my Eclipse go? Not this one. All right, let me just try to do this. Yeah, now we got it. All right. So here it is. So Carl's question is, would I take a performance hit if I used Python? Do you encourage that I use Java for any custom functions? Not really, not really. It's completely okay to use Python or Java. Reason being that there is not much of a performance difference. It's just the first time loading takes time, and since the same function will be called again and again, so I do not think that there will be much of a performance hit. But as we all know that Python is a bit slow, although it's easier everything, Python is a bit slow. Therefore, it does make sense sometimes to go with Java if few milliseconds matter to you a lot. Okay, there'll be very minor performance differences, and those performance differences will be actually eclipsed, or which will be overlooked by the because the processing time will be too huge in general, that these language issues do not surface too much. The differences between multiple language do not surface too much. Okay, okay. So Abhishek's question is, how will we use this tuple data type in Python, or what will we use in Python in place of this? Okay, so I will show you basically the normal object or array can act like a tuple. All right. So normal object or the array can act like a tuple from the Python. Okay, good questions, good questions. So here we are saying that we are creating a class. So this class is being created in order to achieve a very simple thing. We are trying to create a function called upper. And whenever we have to create a function, then we have to create this full class which extends eval func. Okay, and we specify the data type of eval func for which we are extending upper by mentioning the generics, and afterwards we implement a function called exec which takes one input, and then you can return anything. So at the end of the day, you're going to call upper function with the tuple as the input, and it can return any value, right? So you can have a look at here. Okay, so I'm doing the basic sanity check. We are saying input equals to null, then do this. If input dot get 0 is is there, as in the first element in this input is there, that means we'll convert that to the uppercase. All right, and once with that is done, we if the input does not contain any of the values, in those cases we just return null. All right. Once you have written your functions like this, you can export your jar. You can export your jar, and let me just call it pig.txt, pig.txt. All right. So it would be there somewhere in the downloads like this. So now there are two steps to it. First one is that you basically first upload it into Hue. Let's say we go to Hue. Where is our Hue? And we say Hadoop 17, not Hadoop 17, let's say student. and go to the old account. This is we are going into Ambari, not you. I'm so sorry. Okay. Thank you, Abhishek, for the question. His question is, if you want to apply, if you want to apply the uppercase to the second column in the tuple, then we say this. Yes, that is correct. So right now I'm just trying to apply on the first column of the tuple which we are supplying to this to the function. Okay. So there are two ways to copy the data to the Hadoop local. One, by going to HDFS. So we go to HDFS and we say upload files, and we select files and go to downloads. This is where we had put in. Okay. Now we go to the terminal. We go to the terminal, as in, how do you go to the terminal? Go to Hadoop 3 dot no big data, and that's it. Again, I'm again logging into student. All right. So here you can see that there is a folder for sgiri, and you can say Hadoop fs minus ls. Okay. So there should be some file called pig udf. You can see pig test, which we just uploaded. So we can say Hadoop copy to local. We're copying from HDFS to our local directory from sgiri pig. What was that file? It was pig-text dot jar, and we're copying to local folder. Hadoop jar. That's it. Sorry, not Hadoop jar. We will run pig. We'll run pig, and we'll say register pig-txt. Pig-test.jar. We'll say register. So what exactly are we doing? We are basically trying to register our custom function which we have just created. Okay, so like this. So it's registered now. Now we can execute the other things, like we can say load my file, and then we can, all right. Also we can go to my asgiri folder in the HDFS like this, and then we can say, all right, that should convert our lowercase to the uppercase. What exactly have we done? We have loaded the data, and then we have said for each A we generate our I mean uppercase like this. So please note this part, because this is our workspace. I mean the package name. Here you can see that. All right, correct. Great. So now it's running, and here you can see everything is upper caps. You can see what's there inside abc.txt. What was the name? xyz.txt. We can say xyz.txt. Was that it? xyza.txt. Okay. This is small case and this is uppercase. All right. Sounds good to you? So we were able to write a very simple custom function using Java. Okay. If you want to, if you want to download the piggybank.jar, if you basically, there are lots of functions which people have been creating. You can utilize the piggy bank, which is basically a public repository. In this public repository of source code, people keep on committing their code, and you can basically create a jar out of it and then start using as if those are your custom built functions. Okay, so you can start with that. So somebody was having the problem, I mean, not somebody, but yeah, all of you would be having this problem that whenever we say pig storage comma, it doesn't really parse the CSV file. What is the difference between parsing and normally splitting? In case the comma is in between the columns, as in even if the value is in double quote and some comma exists, pig storage will break it into two columns or two fields, right? That is the difference between parsing and normal using pig storage. So there is a CSV parser as part of pig storage. Somebody has committed in piggy bank. You can use that one. All right, and you can use a piggy bank in the following manner. Okay, more detail about piggy bank you can get here. All right, now there is a next interesting topic in Pig Latin, which is called for each nested. What does that mean? It means, so within for each, we can call other for each, and we can also call more functions on each record. All right. So when we call for each, we basically iterate over the records. Inside the for each, we can further go one step further, and we can convert each tuple like various columns of tuple as if they are the separate records, a separate part of the bag. Okay, you will understand it in a minute. Okay, let's say here is a very simple problem. You are given the city name and the people name of all of these cities. Now, what you need to compute is that for each city, how many distinct names are there? How will you do that? You have to find out how many distinct names are there in each cities. So, for each city, you will have to compute distinct names, and uh, after that, you'll have to compute the count of it. Then you report. It's a two-step process. So, anybody? Okay, so Abhishek already faced this problem. All right, so Abhishek says then, Damodaran says for each name, then group by name and city. Okay, try executing that. Correct. So Praveen says that loop through the city, and for each city, loop through the names. Yes, that's exactly the for each does. Let's have a look at the actual code. So if you have this, we can say people equals to load people as city comma name. Okay. And then we can say group equals to group people by the city. Okay. Now we have grouped the people by the city. After grouping the people, here like for Bangalore, it'll be Sandeep, comma Vivek. Now we can do the distinct over this list only if we do the for each. So when we say for each group, the people the people name for that group will become a data set for you on which you can execute distinct. Okay, so you get the distinct name and now you can do the generate. Okay, so more importantly, inside a for each you can call other for each and so on. Okay, and this is very useful to us. All right, so that was one optimization step. Not only optimization but making it possible to do very complex tasks. Okay, now here is the problem to you. Okay, now here is the problem. You should think in terms of map reduce the way we discussed earlier. Let's discuss how exactly you will do using normal map reduce. Let's say you have one table containing a billion entries, and this table contains the name of the person and the country they are living in. Okay, and the country which we are using here is like two letter code. Let's say we want to replace this country name with the zip code or STD ISD code. Okay, now if we think about it, countries are hundreds in count. Okay, while we have 1 billion entries, and if you have to join these two tables, a list containing country and country code and second list containing the list of all the people. So if we try to join them, do you think it would make sense? So we could join them the way we tried to solve the democracy problem. The democracy problem as in we try to do the concatenate the two file, do the group by on the field, and therefore thereby we got all the results for that key sorted together. Okay, now that kind of thing if you do, then you will require a reduce phase, right? You will definitely require a reduce phase in the joining of two tables in the usual manner. Now you could do few clever things. One is, since it's a small data, you could put it in a distributed cache, right? You could put it at a distributed cache so that the table becomes available to all the nodes. Or you could simply load this data into the memory on each node. So if you put it in distributed cache and make this smaller file available in the memory on every node, then you do not need to do the reduce phase. There will be no reduce phase. This joining will finish in the map phase itself. So when we are going record by record in the first table, we will keep on replacing the country with the country code. Okay? And thereby reducing a lot of overhead. And why we are able to do it? Because the second table is fairly small to be loaded into the memory. Okay, so Abhishek is saying we can send the record to the node which has the same country. hmm And how will you do that, Abhishek? Okay, so I think you are also saying the same thing. Basically, take this table and send it to all the nodes using the distributed cache. All right, great. Now, in case of pig, you can do the distributed cache by using the keyword called replicated. When we say replicated, this second table on which we have marked as replicated, it will be copied to all the nodes and thereby doing the rest of the operations. All right, is that clear to everyone? So Damodaran is saying it can be done in the nested for each loop. Okay, and how will you do that, Damodaran? All right. So we are basically, our syntax has not changed much if you see, although our approach is entirely different. So, so the way you are joining, join table A with join table B on the basis of country. Okay. On the basis of country, this will be country, not county. Okay. It'll be country. Okay. So you will join these two tables in the same simple manner. Persons equals to load persons, then CEC equals to load country code, and then we say join persons and CC on country. Okay. And the only thing that is different is this particular part where we are marking that this second table has to be using replicated. Using replicated. All right. Is that clear to everyone? Damodaran is saying, I wrote a simple C program, just like multidimensional matrix problem in, okay. In Python or Perl, just load each data into associated hash arrays and loops through each column, and finally achieve the hash associate table. I'm actually out of context, Damodran. You can drop me an email if it is related to something which we are not discussing here today. I think what you're explaining is the approach here. So, all right, yes, now I get the context. I get the context. Just load each data into associate a hash array and loop through each column and finally achieve the yes. Yes, I think I got it. Yes, it's a similar approach like iterating through the data and going through the another hash table and then achieving the same thing. Okay, so this is called a replicated join. Now, the next step is when you try to join skewed data. Skewed data means the sometimes the when you try to join two data set, one is humongously varying. For some keys, there are so many records, and for some keys, there are too few records. And in these cases, we call it the skewed data. Okay, let's imagine that we are we are mm, we are trying to we are trying to find out all the people, and the key is the country. For some countries there might be a billion people, for some countries there might be only few hundred people. Okay, or cities you can think about. So such kind of data is called skewed, and we call it skewed around this particular field. Okay, so if you are trying to join two data set in which on a particular key around which one data set is skewed, as in for that particular key, for that particular column, for some keys there are billions of record, and for some keys there are too few records, meaning, and that's what we call skewed data around a particular column, right? So when you try to join such kind of table with another table, it might cause a lot of problems. If you remember our discussion around giving the five recommendations, in which for the words like is, am, are, there could be hundreds of billions of words following is, am, are, while for other other words like less common words there could be only one or two words following them, right? So in these cases you will realize that the fields are, I mean, such kind of data is heavily skewed, and essentially what would happen is it would overflow the reducer. And okay, why? Because on a reducer, a single key, all the values for a single key are always together, and therefore it might overflow your reducer. Okay, so if you fear that while joining or something your data is being overflowed, you can simply say skewed, and Hadoop will try to Pig will try to overcome those kind of joins. Okay, so you will still continue to behave as if it's a join, but internally the whole process will be very, very different. Okay, so these kind of keywords, these kind of optimization steps make our life really, really simplified. Okay, so previous one was replicated, this one is skewed. All right. Okay, so in case both the data sets like CINFO as well as users, both of them are skewed around city. We can mark skewed here as well as here. Okay. Now Abhishek is saying they both solve the same issue. No, no, Abhishek, both are not solving the same issue. Here, it is solving the issue of city around city. I think you don't require skewed here. I don't think you require skewed here. In here, either if CINFO or users or either of them is skewed around city, then you can just simply say using skewed at the end of it. I'm not sure here. I can check it, but I've not used skewed in between before. So let me just make a note of it. All right. Okay. So I don't think you have to, in case this table is also skewed around city and this table is also skewed around city. In those cases also, we will just have to use skewed only at one place. Now, question from Abhishek is that do skewed as well as replicated solve the same issue? Okay, so can somebody help? Can somebody answer this question? So, is using replicated and using skewed the same thing? So you use replicated when one of the data sets is smaller. Okay, very small as you can load into the memory. But use skewed when the data in these tables is very, for some keys, there are so many records, and for some keys, there are too few records. Okay. But that does not mean that overall table is small. No. It only means that for some record, there are too few record. For some record, there are too many records. Great. All right. Sometimes when you are joining when you are joining two data sets, what if the data is already sorted? Okay. A quick question to all of you. This is probably a little difficult question than you would expect. Okay. Quick question. Quick question. Sorting the sorted data. Okay. Let me say. First time sorting the data took 10 hours, or let's say 10 minutes. 10 minutes is good number. And then resorting the same sorted data on the same criteria will take, number one, less time, number two, more time, less time than 10 minutes, more time than 10 minutes, and almost same time. Anyone? Abhishek says more time. Shisha says less time than 10 minutes. Anybody else? Okay. Maybe. All right. All right. Let me just tweak a little bit. We say approx, let's say less than 5 minutes, maybe. More time, maybe 10 minutes. More as in maybe 15 to 20 minutes. Almost the same time. Santosh says if the all right, Subbareddy says almost the same time. Less. Carl says less. Santosh says if the results are in memory, then it would take less time. Okay. Arvind says if it's a bubble sort algorithm, then it takes less time. All right. But do you think anybody uses bubble sort anymore? Damodran says that almost the same time. Shisha had changed the her answer to third. Okay. All right. Great. Now Damodaran says depending on the sort algorithm. Brilliant. All right. So actually this was a very big issue in the computing world. When in the beginning there was this binary search tree way of sorting. So this binary search tree was humongously inefficient. Okay, was very slow on already sorted data. Okay, because it was trying to form a tree, and it was forming a tree such that if a particular word is lesser than the node, it goes to the left. If the word is greater than the node, then it goes to the right. And the same keeps on applying. Now, when the data is always sorted, so the full tree is all skewed towards the right. Okay? Full tree is skewed towards the right. Okay? And therefore, sorting the sorted data was taking huge time, right? If you want me to demonstrate, I can demonstrate to you. But afterwards, there were a lot of improvements done in almost every algorithm in the search world and sorting world. So almost every algorithm takes equivalent of time. So the answer is number three. So sorting the sorted data also take the same time as sorting for the first time took. Sorting the unsorted data takes the same time as sorting the sorted data. Okay? Now, Damodaran's question is merge sort takes the same time. That is very correct. Abhishek is saying almost the same time. I think the merge sort same time. That's correct. If we use insertion sort, it takes less time to the first time. So insertion sort and bubble sort both will take the very less time on the sorted data. That's very correct. Okay, good. Thank you, Arvind. Thank you, Abhishek. Sounds good to you? So binary search tree was very, very slow. Then rebalancing the tree, the concept of rebalancing was invented. Okay, great. So sounds great to everyone. Thank you, Arvind. Let me, yeah, yeah. So you can have a look at the sorting algorithms, sorting-algorithms.com. It's quite nice. All right, and moving ahead. So just now we discussed that if we have already the sorted data and we are trying to sort the sorted data, it might be a pain. So also we earlier discussed that when we join two data set, internally it does the sorting. Internally, it is going to form a key on which we want to join the two tables, and then around the key, it will aggregate rows from both the tables, and then it will do the perform the actual join. Okay, so joining is nothing but a sorting operation. And when we are sorting the sorted data, we know that our daily data set called daily is already sorted by symbol. Similarly, our divs is already sorted by symbol. Then we do not need to sort these data sets. So we could skip this step. So in these cases, we could use a syntax called using merge. Using merge will avoid the sorting of this data. And also be aware that in case you are not confident about sorting and you are not sure whether the data is sorted or not, use do not use merge. Okay, it will give incorrect results if you try to use merge over the dataset which is not sorted. It will not give an error saying that your data is already sorted. No, it will just give you the wrong results. So this is the third this is the fourth or fifth syntax to make the process of churning the big data really fast. Okay, these are all optimization techniques. All right. The next thing is people observed that lots of us, whenever we are churning data, we are actually doing two things together. One, one grouping the two tables by the same by on the same column and then joining them together. Was you observed that lots of people are using this kind of syntax where we are trying to bring two tables together, first join on a particular column, and after joining the two tables on a particular column, we are saying group by on the same column. In those in such scenarios, okay, when we are saying group by on the same column and joining on the same column, we could avoid multiple times sorting either by using merged keyword. So if we have joined this table or if we have grouped these tables separately and then we are joining them together, in that case we can avoid sorting of these again while joining. We can avoid sorting of these two tables by marking it using merged, but still it will be an overhead. So if you think about this operation can be easily simulated by using MapReduce, right? All you need to do is we take owners, we take pets, we basically convert owners and pets into key and the values, and then we in a single shot both the works will be done. So if you so in the cases where you have to group on the same column as well as you have to join the tables on the same column, it makes sense to use co-group in those cases. You could simply say co-group owners and pets by this particular column, and it will join the two tables and then it will group them on that particular field. All right. So co-group is another step to make the whole process a little bit faster. All right. We will talk about unions. In case of union is nothing but putting one data set and second data set one top of another. One top of another as in if A has got 4 records, B have got 4 records, total number of records in C will be 4 plus 4, which is 8. Alright? Make sense to you? So when we are joining two data sets like A and B, if we put union together, we are basically saying join these two data sets, put first give the take all the records from input 1 and then take input 2 and put them in the output. It's like cat A and B. All right. If you have used Unix, sorry, in DOS also you have the same command called concat. I don't remember what you call it. I think it's called type, type, type A comma B. It prints the result of A and B. Okay. If you want to, union these while putting these results into the output, you want to kind of try to match the schema. Okay. In those cases, you can say union on schema A and B. So it would look like this. Imagine that A has a column called X and Y, and B has a column called Z and X. If you do a simple union of A and B, the result will be like this. It'll be like, I mean, in not exact order, it will be in its own order. So, okay. So you could basically union these two, A and B. And although the order is, A1, A2, A1, A2, 2, 1 is little off. Okay. So A11, A21, B 21 and B11. Okay. No, I think there's something wrong with this data. So A11, B21. Yeah, it would be generally the other way. I think it's wrong. So it'll be like A11, A2, A21, and then yeah. What is important here to understand is the on schema problem. On schema problem is a little tricky. Okay, on schema problem is little tricky here. So when you do an on schema join of A and B, what would happen is it will form 3 columns X, Y, and Z. Okay, and then fill in the values. Okay, so we'll have B22, which is X, you see B22, B12, while there is no column in B, therefore this is empty. And then in Z, A11 and B21, you can see in the Z. Second, then it will output all the records from A. So it'll be A11, A21, and then Y, and then Z will be empty. Okay, you can see that. So on schema is clear to everyone. So Damodaran's question is, why is B coming first? So generally when you are doing on schema, actually the second data set comes first. Okay. there would not be a guarantee that B would come first or A would come first. Because in a bag, the values are not really strictly ordered. And this is a bag. The data set is a big bag of tuples. These are each row is a tuple. All right? Make sense to you, Damodran? So Damodar is saying, so every time it's run, this command is run, the output will be different. Not necessarily. The output will be same. It's just that it is not easily predictable. The output is not easily predictable. All right. Also, the output might change when the pig version change because they do not guarantee that the first record will come first or the second will come first because a bag is an unordered array. It's like saying select star from a table. Now, Damodaran's question is how do we troubleshoot? The easiest way to troubleshoot is break down the whole query into you basically start from the top or and test the output of each of the data sets, or you could simply say describe, or uh, you could say describe my data set and it will show you the full query plan. Not describe. The other one was you I forgot that command right now. So there was this nice. All right. There, yeah, here it is. So the way you can debug is doing the explain data set and it will show you what exactly it's doing in internally. All right. Yeah. Thank you, Abhishek. That was correct. It was explain only. All right. So we take a break of 10 minutes and come back at back by 10:18 p.m. IST. Okay. back. Are you guys back? Should we start now? All right. Yep. So should we start now? Are you able to hear me? Great. Okay, so what do you think will be the result? Girish says the result will not be there. There will be no result. What do you think? If you have two data sets, A and B, if you say join A comma B, what will be the result? Anyone? Correct. Correct. So we so thank you, Savita. Yes, we need to specify at least one column. All right. So that is the thing with the pig Latin. So you have to specify at least one column to join upon. Okay. So in case of SQL, if you say select star A comma B, you will get you will get a result which is a cross product of A and B. If A has n rows and B has m rows, the total number of rows in the output will be n into m. Okay, so each row of A will be joined with each row of B. That's what happens in the usual SQL. But here it gives it error because when you join the two di- when you try to join the two using MapReduce directly, you will have to create some key and do all the exercise. Okay, therefore pig does not allow you mm, pig does not allow you joining two data sets without specifying the columns. Great. So, but sometimes it's required to do the cross product or Cartesian product, also we call it, which means each row of A has to be combined with each row of B. So for that, you can use another command called cross A comma B, which will basically generate a cross product of A and B. All right. And to make it faster, you can also go one step ahead and specify number of reducers, and that will make it really, really fast. All right. Now, since Pig is going to be used as a reporting tool, since Pig is going to be used as for generating reports, and every reporting engine has these basic features such as parameter substitution. Imagine that you run the report every day. So for every day you have to specify some kind of date. Give me all the records created after this particular date. So you'll have to pass on these kind of parameters, and to do that you can basically say a dollar date or some other variable inside the script. And what is a script? Script is a sequence of the pig commands. Okay, if you put all of these pig commands in a single file, that becomes a script. All right. So daily.pig has got this file. All right, has got this file and this kind of content. And in here, you see this is the dollar date. So you can pass this dollar date from the command line by saying pig minus p date equals to this. Okay, you can say pig minus p date equals to this, and then you can also say on the same command line, you could also say things like, okay, why it's not working. All right, yeah, no worries. Next is if you have too many parameters in a report, you can create a separate params file and you can pass that params file in the command line argument. Because what happens is when you have this piece of code, so this piece of code will be written by a developer and will be executed by operations person, and operation persons do not want to change anybody's code, because if they change anybody's code they will have to maintain the versions of the same code. Although therefore it's very important to separate out the code and the parameters. Okay, and that is why this kind of facilities are provided. All right. Next is that you can split the dataset into multiple datasets by using a command called split. Okay. So you load one particular dataset and then you split that dataset into multiple legs. We call them legs. And these legs are not really mutually exclusive. Okay. One record can be completely dropped, as well as one record can be there in all these datasets. One record can be there in all these datasets. All right. So you can see that when we say split W logs into APR01, APR02, APR03, and we say timestamp is this, timestamp is this, in all of this, everywhere here, you know, you can see that some record, like the record which belong to multiple conditions, so all the records which are here also belong to this data set, and therefore all the records which are there in April 3 will also be in April 2. Okay, and all the records which are say above 2000 this date will be dropped. So basically what am I trying to explain again and again is that even though we are saying split the W logs into multiple, it's not really split. It's like picking up records from W log and choosing which data set to put in. Okay, because some records can be completely dropped and some record can be put into multiple legs. All right, and then you can operate on each of the like do order by, group by, join them, and all of that. Okay, all right. Now whenever we are splitting the data set, whenever we are doing the splitting of the data set, we could do a lot of things here. So even though we'll be splitting and operating on separate data sets, internally it does a lot of optimization, and chances are that multiple map phases will be combined into single map phase, and thus it will improve the performance, and it does improve the performance of pig overall. All right, it does a lot of optimizations, and because it knows exactly what are you trying to do. You have group by, filter by, and order by, and base or for each it would join all of this together into a single map and will try to run it via single reducer. Okay, to for the performance reasons. Also, you just saw you have been seeing this all the time, that a pig script is not really linear. It does not happen that we pick up the pig script and start executing, as in running the code, right? In case of pig, the actual execution starts backwards. When you say dump or store, then it will start executing upwards, finding out who all our dump depends upon and executing only those. This is called non-linear. This is called non-linear execution of the script. Had it been a Perl script, Python script, shell script, the first command will be executed, then second, then third, then fourth, and so on. But that is not the case with Pig script. Make sense to you? Great, great. Any questions at this point? You can go through the further detailing of Pig on these document pages. We are using 0.13 so far in our labs. You can use the same one. All right. So that's pretty much about Pig and Pig Latin. All right. Any questions here? No questions? Should we start with Hive? Okay, we have a question from Damodran. So Damodran says that Pig seems to be similar to unSQL. I'm not much into RDBMS. So actually I have not used unSQL. What exactly is unSQL? Unsql? Oh, that's a language for Couchbase. Okay, okay, okay. Yes, we will be doing the Spark in this course. Okay. Spark, as in we will only cover the basics of Spark and overall architecture view. Okay, we'll not go into too much of detailing, but that will be more than sufficient. All right, great. So we are moving to Hive. Before Hive, do you have any questions? Yes, we have a homework for Pig. If you go into my courses, where is my courses? It is there. Okay. So there is a subjective as well as objective homework on Pig. All right. So you can have subjective and there's a quiz. Okay. So Abhishek's question is, let me just put it here. So this is finished. In such a case as C, comma C1 and C5 and F comma 2 and F11. Okay. Yes, you can use, so for this, you can say for each C and then, and then, and then you can do a for each again. So for each, first for each will give you this list, another list, and then you can say for each again, and then you can manipulate this. Okay? Yes, you can use for each for this. Great, great. All right. Any other questions? So did you guys like this terminal in the browser? So what you can do here, if you want to go to Hadoop 1, if your data is lying on Hadoop 1, what you can do is you can do SSH and student at Hadoop 1 dot nobigdata.com. Okay, so you can do that also. Also, in case you have not downloaded WinSCP, use the browser to upload your file into HDFS, and then you can download into the Hadoop 1, Hadoop 2, or Hadoop 3 using Hadoop FS minus copy to local. The way I copied the our pig file, okay, I did that on purpose so that in case you have not downloaded WinSCP or any other client, you can still you'll not be halted. So Damodaran's question is this a Java virtual machine console? Not really, it's a JavaScript based. It's a JavaScript based. It's connecting to our backend. It's not doing anything. It's connecting to our server, and that's all. Yes, yes. So yeah, Carl is saying that even easier, you could simply say Hadoop SSH1, SSH Hadoop 1, and then you will log in. All right, great, great. So yeah. All right. So feel free to connect all the time, as in you drop an email and at Hadoop at No Big Data, and we'll try to get back to you as soon as possible. Okay. So that was one thing. Now let's start with Hive. All right. All right. So good, good. So Hadoop is great and Piglatin is great, but how would you move existing SQL queries onto Pig or onto MapReduce? Secondly, how would you move the existing users of databases, okay, onto something like Piglatin or Hadoop MapReduce? It's very difficult, and it's not a great idea generally for an organization to take such a plunge that rewrite all the legacy SQL into this new kid on the block, as in new pigletin or MapReduce. It is uneconomical, and it would not be very convenient. Therefore, Hadoop guys basically came up with SQL in the form of Hive SQL, HiveQL, which using which you can churn lot of data, and it would feel as if you are really working on the database. All right, it'll feel as if you are really working on the database. So Abhishek's question is, how frequent is basic MapReduce code used in industry compared to Pig or Hive? So basic MapReduce is actually very rare unless you are doing a big development work. You would not like to get into MapReduce right away. You will mostly live with either Pig or Hive. Also, Also, the other reason with MapReduce is it's even difficult for developers, and there is lot of repetitive logic. You remember the joins? It was such a difficult thing to do the joins, and again, whenever we are joining something on a particular key, we are repeating a lot of logic in case of MapReduce. So MapReduce is quite cumbersome for the small and usual tasks. Okay, so most of the usual tasks can be actually done using a better platform like Hive. So it does not provide record level update, insert and delete, but it can guarantee it can generate new tables. All right, so in case of Hive, let's understand this value first. Using MapReduce is actually difficult game because it requires you to know Java. Second, writing MapReduce is little tricky. We have to keep on figuring out what goes in map and what goes in reduce. Second, it's little lengthy because every time you have to write maybe hundreds of lines of code, and even for usual tasks, you have to keep repeating it again and again. All right. That is why we use Hive. Now, there are limitations of Hive. First, it does not, so far up to 0.13, it did not provide us editing the records. In the newer version called Stinger Update on Hive, that one is going to provide the editing feature on Hive. Okay, but I mean, like you cannot say update record, update table this, where set this equals to that, where this particular condition is met. You cannot do that. But you can generate new tables. You can say select star from my table into where this condition is successful, and save these records into a new table. That is very much possible. Okay. Second is, it's not great. The Hive is not great for OLTP, although it's good for doing data warehousing for the larger data set, but it's not great for online transaction processing. If you have if you have lot of data coming in the real time, then it's not a great idea to use Hadoop or Hive for those kind of scenarios. Okay, because Hadoop itself is batch oriented. And a simple query takes a lot of time. There's always this overhead of creating MapReduce and executing in batch, and batch's psychology is I will get it done, although although It might take some time, but I'll get it done. That is the psychology of Hadoop MapReduce. Okay, so it's only good. Hive is great only when you have large data set. You have large data set to churn, and you are maintaining that data set, and you want to mine that data set. In case you are trying to do a online transaction processing, Hive will not be a great idea. All right, this is how the general ecosystem looks like. You can see there is Hive big box containing a driver. Driver is nothing but given a SQL query, it converts into the map and reduces, which get executed on top of Hadoop. All right, Hive is basically that. All right. So there is one more important component here. It is called meta store. So, like with every SQL, you start with creating a table, loading data into that table, and then further doing the map reduce. Okay. So, okay. So this data, which is there in the meta store, just a second, I think I missed. Yeah. All right. So this metadata will be basically schema things. So I'll show you as we go forward. Before we start using Hive queries, we'll have to clearly define table. Okay. Unlike Pig, where we started with load my data, even if we did not specify that this is my columns, this is the row, we did not specify it, and it automatically figured it out, or it did not bother at all. But in case of Hive, you have to create the table upfront, just like any database. You have to tell what are the columns, you have to tell what are the data type of each column, and only then you start with the processing of the tables. Okay, so that means either every time you execute your queries, you keep on creating table again and again, the way we were doing in Pig. If we exit from Pig, the data sets which we created just vanish. Okay, but in case of SQL, in case of Hive, we want those tables again and again. Okay, therefore, to persist the table information, it uses something called metastore. And a driver can be called from command line, it can be called from web interface, and it can be called using thrift. And you can call thrift either from JDBC if you are using Java, or using ODBC if you're using maybe C# or .NET. So you can use those drivers to access the thrift server. Thrift server internally will be accessing driver and making it work. All right. All right. This is how it would look like. This is how our Hive queries look like. You can see that. So first we copy the data into our HDFS folder. After that, we load that data into one table. Okay. And afterwards, we break it down. Afterwards, we break each of the lines by space, and then making it multiple columns, and then explode it. After exploding, we do the count, and then that's it. Okay, this is how the SQL query would look like for word count example. All right, so you can get started with connecting to Hadoop 1, 2, or 3, and start executing either by specifying the query on the command line or specifying the full file as the argument. Okay, so you can say create table X and provide a column name, select star from X and drop the table X. Okay, So how would it look like is, let me try to show you. Okay, where is my, yeah, here it is. So Hive would look like this. All right. Now from here we can start churning our data. Let me close these. All right, so let's try to create a simple table like this. We are creating a table, then we are selecting from it and then deleting it. Okay. We can say select star from X, says nothing, and we can say drop table X. Perfect. So just like pig, we also have a command prompt here. It's called Hive command prompt. And you can also run the way we were running in case of pig. You can also run HDFS commands. Also, you can load the external scripts. All the commands start with dash dash, and uh, and the environment variables you can define in order to utilize those inside your query. Okay, just like in pig you define the parameters, similarly you can also define the similar things here. All right, so since we have to define in case of SQL, since we have to always define the data table types upfront, this section is important. So Hive's objective from the day zero had been that whatever legacy code people have, you should be able to use that same legacy code of SQL in Hive. Okay, so that so that there is no extra development cost required when we are churning bigger data. Now, now here you will see that for string there are three kinds of data types: string, var, char. For binary, I mean bitwise, you have two data types. One is boolean, other is binary. And for date time, you have these three data types. Now, why do we have these many? The reason is Hive's objective is to make the older queries work on Hive as such. Therefore, they have tried their best to have all the data types which are there in Oracle, MS SQL, or Postgres or MySQL. They have tried to do that a lot. Okay. Reason being, Hive's core objective is those people who are not familiar with MapReduce or Pig or newer technology, they can continue to use Hive in order to churn the big data. Okay, so other than the basic data type like boolean and an integer and string, you have complex data types. These were not very popular in case of MS SQL or MySQL, but in case of Postgres there are these complex data types. First one is arrays. Arrays is you define the data with array keyword, and you also define what is there in the what kind of data type that array would contain. So a field in your table can have an array. Inside a field you can have an array. Okay, or inside a table, let's call it inside a column of a table, you can have an array. Similarly, we could also have a hash map kind of data structure called map. And this map, if this map can only have key which is string, while value can be complex type or primitive type. Okay, now there is another thing called struct. Struct is like your normal object in which keys are predefined. while values we can set. Now the fourth one is union. Union is just like your C, a data type which can hold multiple kind of values but only one at a time. So let's imagine that you are maintaining the user's information. Your user can either come from Facebook, Google, or anywhere else. They can authenticate from anywhere. So you just maintain one column which basically holds the authentication information from whether Google, normal email ID, or Facebook ID. But one user can only log in from one kind of such streams. Therefore, therefore, auth will always have a single value of type either the string, integer, or the string. Damodaran's question is Hive seems like Hive is treating everything as byte stream. Not really. It tries to decipher the data and tries to formulate it as if it's a database. Okay. So that was our data types, complex and primitive. All right. So to separate out one our work from one person to another, we could use the databases like this. Okay. We could create the namespace. We could create the database. Okay. A database means we are multi-user environment, and every user wants to keep their data separately. We could create the data. We could create the database, and in which we could keep on doing it. Okay. So we can simply say here, where is our console? Yeah, here. We could say show data. Is the font visible? I'm not able to increase it. Yeah, is it good? Show databases. Okay, so these are the various databases. I have my own database. I can say use as Giri. Okay, and now we can say show tables. These are the tables existing in my database. Okay. All right. Good. So you can create your own database using create database, in which you can put your own stuff, and can separate out your tables from other users. Also, you can, if you like to display the database current database in the command prompt, you could use a syntax like this. And okay, I need to remove this. Yeah, can see that now it is showing me the okay. So you can see the tables using show tables, and further you can dig down using describe, or you can say describe extended or formatted. My favorite is using describe formatted. Okay, so you can say show tables and it will show you all the tables. Then you can say describe, and you can say employees. Okay, like this. So it shows you that this table has got one, two, three, four columns. Okay. If we see another one, okay, there is no another one. Let me see this. Yeah. So let's say we pick up this table and say describe, and this column. See that. All right. Now it shows that it has got three columns. If you want to go into more details about the table, we can either say extended or we can say formatted. I prefer formatted because the output is very clean. So it shows you all the details about this table. You can see that. You can say see that we are saying describe formatted and the table name. It shows you that these are the columns, these are the data types, and then the further information about this table. Sounds good? Sounds good. Any questions for me at this point? No questions? All right. Any questions? Anybody? All right. Basically, when you deal with tables, in case of Hive, there are two different kind of tables. One is called managed table, other is called external table. A managed table or internal table is good when you own the data, because the only difference between managed table and external table is if you drop a managed table, the underlying data will get deleted. But if you drop an external table, the underlying data will not get deleted. External table is more like, the creating a symbolic link to the file. If you create the link, the actual data remains. But in case of managed tables, the data gets deleted. Okay. So managed table or internal table, lifecycle is managed by Hive. Data is stored in the file you added. Okay. All the tables which so far we have dealt with have been the managed one. External table lifecycle is not managed by Hive, and Hive does not assume that it owns that particular data, and metadata will get deleted if you delete the table in the Hive, which is external, but the actual data will not get deleted. Metadata as in what are the columns, all of this information. So metadata will be deleted, as in the table get deleted. So metadata get deleted, but it does not delete the original data. Okay. So as a thumb rule, whenever you are churning the data, anything you want to be deleted, create it as any data that is being created by you should be deleted, and therefore created it like managed table. But if you are accessing an external data, do not try to delete that. Okay, and therefore make sure that you have an external table. I've seen many students making that mistake, and that keep on happening inevitably. All right. Now we have Hive Metastore. Okay, as I was telling you, if you have been following so far, in case of pig, if you exit and log in back, all the data sets which we created is no longer visible. If you start a pig session again, the data will just disappear. There was nothing left, right? But in case of Hive, we cannot do that, because here there is a too much of an overload load. Every time if we have to every time while defining a table, we have to define the columns and their data types, and therefore it's a huge overhead to create is a huge overhead to keep on creating the table again and again the way we were doing in Pike. And that is why Hive Metastore is there. Metadata is persisted across the session. If you created a table, it will be there forever. You can delete it, but yeah, as if you do not delete it, the table will remain across the multiple sessions. Are you guys with me? No? So Abhishek, Arvind, Damodran, Girish, Sirisha, Kal, Kurupa, Praveen, Santosh, are you with me? Si- and Savita, Subbareddy, Urs. All right. Okay. Okay. So managed versus uh, external, Arvind. When you delete a managed table, the data will get deleted. External table, if you delete it, the data will not get deleted. It's as simple as that. Okay. All right. The meta store basically stores the information about table. I'll show you this. I think that will be more interesting. So if we go into Hadoop one and we say MySQL, okay. And so as I was telling you that our data is stored, any table we are creating, the table is there forever, right? If you go into Hive, you will see that. But here, if you say MySQL, this is where Hive will be storing the Hive will be storing the data. So you can say show databases. Right now I am in MySQL. So databases. You see, uh, and let me just exit from here and say login from root, and then say show databases. Yes. So now you can see that there is a database called MySQL Hive in the MySQL. Okay, but inside the, let's say we go into Hive, right? Inside Hive, inside Hive, you will see these tables, these nice tables. These are the tables that contain the metadata. Okay, these are the tables that contain the metadata. Any table you create, the entry is made into this. Okay, every time you create a table in Hive, an entry will be made into this table. Okay, because this meta store is actually stored locally and is actually this meta store is essentially on a single node of MySQL. All right, let's try to create a managed table. A managed table looks like this, so we can simply create a managed table. Let's create a database for this session. Let's try to create a database for this session. Go into Hive. Okay, I'm so sorry. All right. So here, let's try to create a database. Create database, and I'm giving it a name called, let's call it July 11. So we can say use July 11, and inside this, we are creating a table called NYSE daily. It has got these columns. You can see the columns here, these columns. And we got exchange one, which is string, symbol one, which is string, and so on. Okay. We can also say describe NYSE daily and one. So it shows you all the details about this. Also, please note these last two lines where we are saying that this data, which is in NYSE daily, when you store it or load it, please use this particular delimiter. Fields are delimited by tab, and the location of the data is this. So whatever data you insert into NYSE daily 1, it will be inserted at this location. If this file already exists, then you can right away start using NYSE daily. Okay, let's try to check if we have something. Select star from NYSE daily. There is nothing in this table as of now. Okay. Now to load the data into the managed table is very straightforward. You could say things like this, and it will copy the data into here. Okay, and our table name was 1. Table name was 1. Okay, so you can see that we have copied the data from this file. This is a local file in Asgiri home directory containing New York Stock Exchange everyday data. So here, so is it clear to everyone? So we have done two steps. One was first we created a table, then we loaded. This create table was never done in case of pig. Okay. So we loaded the data, and how we are loading, we are saying load data local. Local is the keyword, meaning it will pick from the local machine, not from HDFS. If you skip local, then it will try to find this file in the, it will try to search this file on the server, on the HDFS. Okay. Okay, so first we created a table, then we loaded data. We are loading data from local file, not from HDFS. If you do not mention local, that means we are trying to load the data from HDFS file. Okay, and also whenever we are copying the data from local file, it will be first uploaded into HDFS and then it will be loaded. But in case you already have a file in Hive, if you already have a file in HDFS and then you're trying to load it, that data will get deleted, or you can say the data will get moved into Hive. If you're trying to load data from HDFS, the data gets moved. Okay. So if you say things like this, if you say things like this, not like this, like here. So what exactly am I doing? I'm copying this NYSE daily into my HDFS folder. Okay. After that, I'm trying to check if it is there or not. If it is there or not. Yes, it has been copied. Next is we try to load this table now instead of a local table. Okay, let's try to load this table now. I mean data into this table. Okay, from HDFS. So this is the file we just copied in the previous step as giri/nysc daily, and from this file we are trying to load into nysc daily 1. Okay, now this file, since it is existing in the HDFS, it will be moved. It will be moved. Okay, so let me start Hive again. So all right, so now if you see, it says that it is moved. Okay, we are loading the data, and it has actually deleted the original data. Reason being that whenever we keep a file in HDFS, it is anyway being copied 3 times, right? So it's a very big waste of space if you try to keep on copying the data. It's like if you are moving file from C colon to C colon, the file will get moved if you drag and drop. In the same way, if you are loading the data from HDFS into your Hive, the original data from HDFS will get deleted. Okay, so now you can see the data has been deleted. If you exit out of Hive, you will be able to, okay, there is no such file existing. So Abhishek's question is, so if we have CSV file and can we use comma instead of /t? Yes, definitely. That was exactly the objective of showing you that you could define a delimiter. All right. Next is, so that was how you load the data. In general, if you do not specify a separator, field separator, it's assumed to be control A, and it will create the directory for that partition, if any, then copy the data. If the target table is not partitioned, it will, and I mean, then it doesn't create the partitions. We'll talk about partitions, don't worry. Okay. And in case you do not specify this location, you see this location, then automatically it will create the file in /data anyway. Okay. So here when we say select star from near, all right, so we can start using this kind of syntax immediately. Like here, you could go into Hive and we can start doing the map reduce. Right? I mean, instead of map reduce, we can start using the SQL, which will get executed immediately. So we can say July, and let's say what was the database? I think it was show databases. Okay, do you see any? Yeah, JUL 11. So we can say JUL 11 and we can say show tables. So we have this. Let's try to do select star from NYSE daily 1. All right. And also, let it stop, I think. Will it ever stop? Let me just log in from here till then. SSH student at Hadoop 1.nobigdata.com. I'm logging into student and then running Hive. Okay. And then I'll be running this particular query. Use JUL11. Okay. And then we do. So it says, I think it's symbol 1. Yeah. Now you can see that when we say select star from my table, my column equals to this. Under the hood, it is also running the MapReduce. Can you see that? Under the hood, it is running the MapReduce. It has given us the tracking URL. You can go to this URL and check what's going on. Correct? Now, Praveen's question is, okay, so Damodaran's question is that where is the table NYSE created? Okay, so the table by default is created in a folder called data. I'll show you that. That is where it is created by default. If you have not specified the location, okay, and when we say table means two things: data and metadata. Metadata means these are the columns, this is the name of table, this is the name of columns, these are the data type of columns. All of that comes under metadata. Okay, so the metadata is created in metastore, while actual data is by default created in a folder called slash data. Okay, if you have not specified a location. Does it make sense, Damodran? Now, Praveen's question is, if we moved data from HDFS, we have to run batch program where the data will be picked from HDFS or Hive. So the data will be picked from HDFS. Yes, metadata is stored in MySQL. That's correct. All right. Is everyone with me? Okay, so I think that was the next screen. So if you do not specify the location, then it automatically creates in HDFS folder at apps hive warehouse. You can go to Hue and you can check that out. Okay. Or if you have mentioned a location, then it will take care of that location. It will try to create the data in that location. And to save the data, as in to export the data, you can simply say things like, if you have to save the data to or to have to export data from Hive into normal file, what you could do is you could say you could say insert overwrite local directory and select this. So whatever is resulted because of this select query, it gets written to this particular folder. Okay. No, actually, yeah. All right. This way you can export the data from database table into local file system or into HDFS. If you don't mention local, that means it is going to go into the HDFS. All right. Now, Arvind's question is, do we need to create unique indexes also while creating the table? There is no such thing called indexes. Okay. There is no such thing called indexes in Hive. Damodaran's question is, you created a database called July 11, but after that there was no step of creating a table with scheme. I actually created there. You just missed that part. So I created a database and after that I said copy pasted the definition of create table and then the table got created. After that I ran a command called load and then the data got loaded into this table. So Arvind is saying that it took around 48 seconds to fetch just 252 rows. It's not a problem with that Hive. It's a problem with this web viewer, or you can say the this VETI, as in it's a problem with the browser. It's still stuck. If you see, for me, it is still stuck. So Damodaran is saying if you can walk through the console logs right from HiveDB creation when you get time. So actually what you can do is you can start from here in this is where it's going. Okay, so first we created a database. You can see we created a database here. After that we created a table, manage table, then loaded data into it. Okay, you can try the same thing. What will be the file names that are created in the HDFS, or directories will be created for each select query? Brilliant question. So actually directories will be created for each database table. I will show you. So whenever you are creating, if you go into not this, yeah, this folder, you will be so for each of the, if you have not defined a location, then by default, this is the place where it gets created. I'll show you. Here. Okay. So for each of the tables which we are creating there, one corresponding database is being created here. Database as in a folder is being created. So let me check if, yeah, here. So we have created one database. For that, it has created one folder. And for each table also, it will keep on creating one table. Okay. Like for Anand, there is this folder. Under this folder, these are the tables which he has created. Okay. Under each of the table, there are files. We call them partitions. If there are, as the data grows, keep on growing big, more and more files will be there under this folder. Okay. This folder will contain all the data of word count. Make sense to you now? Is it clear? All right, great, great. Now going ahead. So this is where the data is stored. This is how we export the data. Now, sometimes when your file is really, really big, you, yes, Damodaran, this, all of these classes requires a lot of practice. You're right. So go through these cases again, do it by yourself, then the things will be far more clearer. All right. So if you have a big file and you have a huge file, and what you want to do is for certain kind of request you want to send to one file, and for some kind of request you want to send the data from another file, and so on. In those cases, to avoid the full scan, you can create something called partition. You can create multiple partitions of the same table. Okay, you can create multiple partitions for a same table. So data is stored into different files based on various combinations of the column on which we have created the partition. Okay, so let's say we have created a partition called age. So there'll be one file for age equals to 20, then another file would be there for age equals to 30, and so on. Okay, so we can create those kind of partitions. Also, I mean, whenever you are creating a partition, you have to define at the table level saying this table is partitioned by a particular column. Okay, also partition can happen over multiple columns, and you can also add a partition later. All right, so this is an example where we have a table called we have a file called the amp. The amp looks like this, and we have another file called the amp1. In this, let's just go to this folder. Let's just get out of it. So here, all right, so let me just go into this folder, cd, cd, and under this you have these two tables, the amp and the amp1. Okay, now what you are doing is, okay, so you have one table for this data and another table called this data. Now let's say you're creating a table, and you know that for qualification number 1, the data lies in this table, and for qualification number 2, the data lies in this table. Okay, in these cases what you can do is first create a table. After you have created a table, you can load these multiple files into this table, specifying the value for the column which for the partition column. So here we'll say that this table is has got a partition column called qualification, and while loading the data into this table we will specify that this particular data has to go into which partition. All right, so we'll continue from here tomorrow at the same time. All right, not the same time, will be early tomorrow by around 4 minutes. Okay, is everyone with me? Or all right, Thank you very much. See you tomorrow at the same time from 8:30 IST, 8:30 p.m. IST. And bye bye. Have a great day.